All right, for the homework for this first video here, I'm going to have you copy these problems down 3 times. So that will be for full credit. This first problem here, you need to solve each equation separately and then compare it. What I'm going to do first, I'm going to see what that answer is and write that really clearly, and then I could clearly see each answer and compare it to it. So that answer is x is greater than -5, where x stays the same, and that greater than symbol has no equal line under there, so x is just plain old greater than -5. So when I solve both equations, or all three, first one I do here is subtract 12 on both sides. Bring down the 2x. That gives me 2x less than -10. Next step is to divide both sides by 2, and that gives me x less than -5. So that one is no good. I'm not going to choose that one. Next problem, same thing. Going to start by subtracting 12 on both sides. Those cancel away, bring down my 2x, my inequality, my -10. Next, divide both sides by 2, and that gives me x is greater than -5, which matches that answer. So obviously that one will be the one I choose. The next one, I'm just showing you a typical mistake that people might make, and subtract that 12 and get -14, divide by 2, and that will give you x greater than -7, so that one is not the right choice. Someone making a mistake there, negative rules might get 10 there. So that is choice B. The next problem for substitution, I need to solve one of those variables or one of those equations for x or y. So I'm going to take that bottom equation and I'm in one step going to solve it for y, which makes it easier of the two. So subtract 3x on both sides, and what that does when that cancels away, that gives me y all by itself, and I get y equal -3x plus 9. I take that -3x plus 9 and I'm going to substitute it into the other equation's y. So wherever there's a y, I'm going to substitute that in. Everything else stays the same, only that y gets substituted. So when I do that, I get 4x plus 5, and where that y used to be, I get the -3x plus 9, and then equal to 12. First step right there, I need to distribute, so I'm going to multiply that 5 times the -3 and the 5 times the 9, and that will give me 4x minus 15x plus 45 equal 12. Next step is to combine like terms. So I'm combining 4x and -15 to get -11x plus 45 equal to 12. Now I could start my inverse operations. So I'll start by subtracting 45 on both sides. Going to use red for that. Subtract 45. Those cancel away. Bring down the -11x. Make sure you bring down that negative. Now the tricky part, 12 minus 45, you're going to have a problem just like this on the final, so be ready. So I'm going to take the difference of them and keep the sign of the bigger number. So obviously right here I make a little mistake on my arithmetic, but I will fix that. But again, I'm going to take the difference of the two, which means the bigger minus the smaller one. And then I'm going to keep that negative sign because there's more negatives than positives. So with the right arithmetic, with that 45, taking the difference away 12, that gives me 33. And since there's more negatives than positives left over, that's -33. So be ready for that. That will be tricky. There'll be a problem exactly like that. Be ready. Next step here, the opposite of multiplying by -11 is dividing by -11. cancels away and gives me positive 3. So after all that, I get a nice, neat whole number. Take that 3, which is x, and replace it into either of those equations to solve for y. I believe that bottom one is probably going to be the easiest one. So with that 3 there and x being plugged in as 3 plus that y equal to 9 gives me 9 plus y. And again, right here, I'm showing you where I'm taking that 3 and plugging it in. And by far, that's the easier of the two equations to use to then solve for y. So back to that equation, 9 plus y equals 9. Take away 9 both sides, and that gives me y equals 0. So that answer is the coordinate x is 3 and y is 0. If you were to plug that in, it would work. 4 times 3 is 12, 5 times 0 is 0, 12 is 12. 3 times 3 is 9, 9 plus 0 is 9, so that point will work if you were to plug it in. My next check I will show you. Last problem on this page, and again, these problems are exactly like you're going to be doing on the final, so be ready. Solving this last one by substitution, number 3. Again, one of these equations is already solved for, so it's ready to go. So that y tells me where in the other equation I'm going to substitute. So wherever there's a y, I'm going to substitute that in. Be real careful. Right here illustrates a typical mistake. I took that 2x plus 3 and I substituted it in for x instead. And again, that doesn't go into x in the other equation. That 2x plus 3 goes into the y. So I'm going to fix that mistake. So that'll give me 3x plus where that y used to be, 2x plus 3. And then that equal to negative 12. Right there, I'm going to combine my two like terms, and that will give me 5x plus 3 equal to negative 12. Right there, I can start my inverse operations, and pardon me as I bring that up. So as I do that problem there, I'm going to subtract 3 on both sides. And that gives me 5x equal negative 15. Divide both sides by 5, and that gives me x equal negative 3. To solve for y, take that negative 3, and where there's a x, I'm going to replace that x with negative 3. I'm going to choose that top equation because I think by far that's the easier of the two. So that gives me y equals 2, and where that x used to be, negative 3. And right here in yellow, I'm going to show you where I'm substituting in. And again, that one was by far the easier one to solve for y. And that negative 6 plus 3 gives me negative 3. So that point is negative 3, negative 3. That is my solution point. And to show you a check, I'm going to plug that into both equations and show you how it works. So first equation, plugging in negative 3 for y from the coordinate equals 2 times negative 3 plugged in there from x from the coordinate gives me negative 3 equal negative 6 plus 3, and then that is a true statement. Negative 3 is equal to negative 3. Plug in the next one. 3 times negative 3 where x used to be minus 3 where y used to be gives me negative 9 minus 3, and that gives me negative 12 equal to negative 12, which is another true statement. Last of the page. All right, for this one, I'm going to solve this one for y. So I'm going to get rid of those 4x and that -3. So I'm going to start by subtracting 4x on both sides. Then I'm going to bring down -3y equal to -4x plus 6. Divide both sides by -3. And again, that -3 breaks up into both parts separately. So that gives me y equal to, when that finally simplifies down, to y equals 4 over 3x, positive 4 over 3, minus 2. And that's because 6 divided by -3 is -2. So if we were to graph that, that would be a y-intercept of -2, and then the run of positive 3 and a rise of 4, so over 3, up 4. Solving the system of inequalities. To solve this system, I'm going to make sure they're both first solved for y, and it looks like that first one is, and that second one. So that first one has a y-intercept of 1, so I start at 1 on the y-axis. Looking at that number in front of x, which is my slope, which is 2, made into a fraction that is 2 over 1. So from that starting point, every time I went over 1 for my run, I went up 2 for my rise. And then I went both directions for that. That next one has a y-intercept of -4, so that's where I start on the y-axis. That number in front of x is -1, so -1 made into a fraction is -1 over 1. Which just means from that starting point of -4, every time I run over a box and go over, I will go down. So over 1, down 1, over 1, down 1. Make sure you stair step both directions to get that straight extended line. That will be a solid line because of the inequality. The other line is dotted because that inequality has no equal line under it. First problem, or the line in black, that is y is less than, so that means I will shade below. So everything below that line is a solution to that inequality. And the next one is more than, which means shade above. So everything above that line is a solution. So my solution area there, to show that, I'm going to shade that in, that one part of the graph where the overlapping shading areas overlap. So every point in that shaded region, except on that dotted line, is a solution to that set of inequalities. And I believe I will do a quick check here. So I believe I'm going to take the point 0, 0, which is in the solution zone. Plug in x is 0, y is 0 into both. So that gives me 0 less than 2 times 0 plus 1. And that is a true statement. 0 is less than 1. Plug in 0, 0 into the other inequality gives me 0 greater than or equal to -0 minus 4. And that is true also. 0 is greater than -4. So that check proves that that area is the solution to that set of inequalities. Here is a bad check. So if I pick one out of the area, this is the point 0, 3. It looks like it will satisfy one of the inequalities but not the other. So when I plug in 0 for y, 2 times 3 for x, and I believe I make the mistake right there. I will go back and fix this. I should not have plugged in 0 for x, or 3 for x. I should have plugged in 3 for y. So I will go back and fix that. This one is correct though. I plug in 0 for x, and I plug in, I'm not sure I did that one right either. Check. I believe I will go back and fix this. So I should plug in 3 for y. and 0 for x. That gives me 3 less than 1. That is the false statement. That is no good. The other one, if I plugged in 3 for y and 0, that would have given me 0 greater than negative 4. And that one, 3 greater than negative 4, that would have been a good statement for that one. So sorry about that bad check right there. You will not need to check on the final exam, so do not worry about checking it. And then the last one here. I'm going to solve both those inequalities for y first, and then I'm going to graph them. So that first inequality, 2x minus y, I'm going to solve that by subtracting 2x first, and then I'll solve for that negative y. So 2x minus y greater than or equal to 1. Start by subtracting 2x on both sides. And that gives me negative y greater than or equal to negative 2x plus 1. Next step, to do the opposite of multiplying by negative 1, which is dividing by negative 1. That cancels away and gives me a positive y. That inequality will switch because I'm dividing by a negative 1. So that become y less than or equal to the negative 2x divided by negative 1, and the 1 divided by its own little negative 1. We'll simplify that down to y less than or equal to positive 2x minus 1. So I'm going to go to negative 1 on the y-axis. Looking at that number in front of x, which is 2, made into a fraction, means from that starting point of negative 1, I'm going to go over 1, up 2, over 1, up 2, and then make sure I go stair step it in both directions, over 1, up 2, both directions. That will be a solid line because of that inequality. If it's a plain inequality, it will be dotted. If it has that equal line, it will be solid. This is shaded less than because that is y less than or equal to. Shade below. Solving that next inequality in one step, I will solve that for y. So I'll just start by subtracting x on both sides. That gives me y greater than or equal to negative x minus 4. So for that problem, negative 4 will be my y-intercept. And then that number in front of x is negative 1. So that slope is negative 1 over 1, which means from that starting point of negative 4, every time I go over 1, I go down 1, over 1, down 1. Make sure you stair step that in both directions. That will be another solid line. I'm going to extend that black line. Make sure when you're drawing these lines, the system, draw your lines as long as possible to make it clearly easy to see. That one is y is more than, so I will shade above that blue line. So in the shaded area above. I'm going to fill in where they intersect. I'm going to do one check, and that will be it. So plug in the 0.20. So 2, replace x with 2, minus 0, greater than 1. That is true. 4 minus 0 is greater than 1, so that's true. And then if I plug in the next one, 2 plus 0, that is also greater than 4. So remember, for full credit, you will need to do these problems 3 times each. You have until the final exam to get this done. So good luck.